Hey folks, so this is the first lesson of the electrostatics unit. Electrostatics is more commonly called static electricity. It's the behavior of charged objects where the things that have charge don't spend a lot of time moving. And so that's why we call it static, because the charges tend to stay where they are. We will talk about charges moving, and then in the circuits unit we talk about charges moving continuously. So that's kind of what separates the next two units. Electrostatics is all about this idea of charge. So like mass, charge is a fundamental property of things that have atoms. So the variable for charge is either a capital or lowercase q. Capital if we're talking about something that has a lot of charge, like a lightning bolt. Lowercase if we're talking about something that doesn't have a lot of charge, like an atom or an ion. Charge has a mysterious definition, the property that causes objects to attract or repel other objects. So we understand the mechanism, I think, as far as like a physics community, but I don't have a great explanation for it. So we say that charge is the thing that causes attraction or repulsion of other objects. So it can exert a force on objects because it has charge. So this idea of charge can be, an object can have a positive charge, a negative charge, or zero charge. When something has a charge of 0, we call it neutral. The unit of charge is the coulomb. All the units in this unit, all the units of measurement in this unit of physics are named after people, and so you'll see lots of capital letters. Charge is carried by subatomic particles. So just a quick review. The proton is one of the subatomic particles. It has the symbol P plus because it's positive. It's in the nucleus, and the charge of a proton is equal to positive 1.6 times 10 to the negative 19th coulombs. More on that later. The neutron, symbol N0, because it's neutral, is also in the nucleus, and its charge is equal to 0 coulombs. The last subatomic particle is the electron, symbol E minus, because it's negative. It's outside the nucleus. And the charge of an electron is negative 1.6 times 10 to the negative 19th coulombs. So you'll notice that the electron and the proton have equal and opposite charges, and that's very important. A little secret, the neutron has a charge of 0 because to make a neutron, you take one proton and one electron and smash them together. And you get a neutron out of that. You get something that's very stable, and the charges cancel each other out. Everything is made of these substances, or these particles, and so everything has a charge based on that. For that reason, we say that charge is quantized. This 1.6 times 10 to the negative 19th coulombs is the lowest allowed charge for anything that has a charge. You can't have an object that has a charge of 1.2 times 10 to the negative 19th coulombs, because that's lower than the charge of a proton. Also, you can't have anything that has a charge of 2 times 10 to the negative 19th coulombs, because that is not a multiple of this, right? So one proton has this charge, 2 protons has double this charge, and no object in the universe has a charge that's in between that. It's kind of like volume on your phone. You press the buttons on the side of your phone and the volume goes up or down, and you get 10 bars. You get 10 possible volumes. You get none of the volumes that are in between that. So, if depending on the room you're in, maybe 5 bars is not loud enough, but 6 bars is too loud. Volume is quantized, and you can't get all of the volumes that are possible in the range that you have. Okay, so there we go. So charge is carried by that. Now, this is a really inconvenient number to think about. So the proton gets a charge of positive 1. And so kind of one thing that science does, and you would have seen this in chemistry with the mole and Avogadro's number, is we make easy numbers so that we can compare. So instead of these like scientific notation numbers, we say the proton has a charge of +1, neutron is 0, and electron is -1. So, you know, our little chemistry review is if we have the magnesium 2+ ion, it has the following properties. It has 12 protons, it has 10 electrons, and just for the sake of like saying it, it has 14 neutrons. And so something you did in chemistry is kind of like translate between these ideas. So 12 protons has a charge of +12. 10 electrons has a charge of -10. 14 electrons has a charge of 0. And the total charge is +2. And that's the charge of that ion. And so we're going to take that sort of idea and translate it to big objects that we don't even know necessarily what they're made out of as far as a chemical formula, but we can like infer what they are. And so that's kind of most of the first lesson. The last lesson has to do with Ben Franklin, or the last part of this lesson. Ben Franklin is one of the people credited with kind of founding the study of electricity. Now, he definitely wasn't the first, but he had a lot of ideas. And so one of his ideas was, it had like so many consequences. And his idea said the charge of amber. When I was in high school, I knew what amber was because I saw the movie Jurassic Park, and so the mosquitoes that had like the dinosaur DNA were encased in amber. So basically like tree sap that hardens. So the charge of amber, when rubbed with fur, is negative. I can spell negative. And that was not a statement of scientific fact. That was actually a decision. Because in this universe, if we didn't study the fact that protons are positive and electrons are negative, we are actually never able to tell. There's no reference charge that we all know and can agree upon that is positive or negative. So Ben Franklin made this decision. When you take this like hardened tree sap and rub it with animal fur, he said that the amber becomes negative. And this idea established the idea of positive versus negative. And so that had a lot of consequences. Okay? In the next video, we'll talk about some of those consequences.